Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Developer Express. Become a UI superhero with DevExpress controls and libraries. Deliver elegant.NET solutions that address customer needs today. By leveraging your existing knowledge, you can build next-generation touch-enabled solutions for tomorrow. You can download your free 30-day trial at dx.hanselminutes.com. That's dx.hanselminutes.com. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and today I'm talking with Eric Normand. He's the chief instigator at purelyfunctional.tv. It's purelyfunctional.tv. Very nice top-level domain there.
Hey, thanks a lot.
That's pretty cool. And there's a ton of resources up there, video courses and courses with free content. And there's a whole section on getting jobs around functional programming. You're kind of building your own portal here to introduce people to functional programming specifically as a career.
That's right. Thanks for making me feel old, by the way, about portals. But I'm trying to help people who want to get a job in Clojure, transition their career to functional programming, and just provide like a ramp for that.
Why do I want to transition my career? Can I have my cake and eat it too?
So there's a lot of people out there who have been doing Java or some other language and been unhappy with it. You know, they were just like, this is all there is. And now with all this like booming of new languages, they actually have a lot of choice, and they are, older, they have a family, so they can't really risk a pay cut. And so there's a lot of fear about changing careers at this point in their life. So I'm trying to be there and, hold their hand and show them that it is possible.
So why Clojure? Why did you focus on Clojure as your entry drug into the functional world?
So that's a good question. I've always been into Lisp. I guess I started back in college, 15 or 16 years ago. And I was kind of a smug Lisp weenie using Common Lisp. And then when Clojure came out, I gave it a shot and haven't looked back. So I just really like Clojure.
I'm going to parse something maybe more than I need to. You said smug, and I think that it's okay to say this, that sometimes people who aren't functional programmers feel a little afraid to get into functional programming, not just because it's scary and they have to figure out what a monad is, but that there's a certain amount of barrier to entry around the personalities of or what may be perceived as personalities in the functional programming world. Do you think that that's true?
I definitely see that the perception is there, and I can see why.
Yeah. So how do we break that down, and why is that perception there? Is it just because mathematicians go into functional programming, or how did we get that stereotype, and how do we break through that stereotype?
Wow, I wish I could break through the stereotype. The reason I see it's there is that functional programming, because it's more mathematical, has been much more target of academic research. So a lot of the people who write stuff online, who write papers, they're actually researching, new computer science techniques and concepts. And so they're just used to speaking in a more academic way and much less practical. They're not even worried about the practical at the moment. They're just trying to get a paper published. And so when you read a blog post, it could be someone who's exploring this stuff, and they could be a researcher, and it might seem like it's totally inaccessible. Like they're using, half the words that they use you don't even understand. It would take you 10 years to read up on all the stuff that they know to get to the point where they're at. But the thing is, functional programming is very practical, and it doesn't have to reach those heights of, novelty that you get in the academic papers.
Okay. So I don't have to be an academic. I don't have to have a master's degree if I want to get started in thinking about functional programming. And I can really do practical work. I can, people who are listening might be doing text boxes over data, got to do a website, and they want to do it in a different way and maybe a better way.
For sure. And one of the things that Clojure has, just as an example, is it's just got this pragmatic philosophy. It's built to be hosted on the JVM. And one of the reasons behind that was to take advantage of all of the JVM libraries that are out there. So it has really good interop. So if you just need to, send some web requests or read some files off of your disk or whatever, you can just do it by calling into Java. And you don't have to worry about, whether you've got the right types and things like that, like you would in some functional languages.
Do you think that and this is going to be kind of a trick question, not a trick question, I'm setting you up here. Do you think that we made a mistake as a community or as a practice that maybe imperative programming shouldn't have won, and that functional programming should have been the thing that became mainstream? That things should be inverted?
You're opening up a can of worms.
Well, but it's, an opinion is an opinion, and it's a valid one. Betamax was a superior videotape format, but VHS won. But that doesn't change the fact that Betamax was in fact better.
Yeah, but when you say that about Betamax, you don't have a flame war ready to start.
Well, I don't want to start a flame war. I want to enable people who are listening to make a decision that maybe there's a better world out there. I haven't decided yet for myself. Maybe the answer is somewhere in between.
Sure. Well, all joking aside, I think that procedural is actually pretty a pretty good model for how things work. What I would say is it's the object-oriented that is not so great. That procedural is great for a single-threaded, just go through step by step, get something done. And, a lot of my code is just like that, even in Clojure. Yeah. But what happens is once you have multiple threads, you actually want the language to help you a lot more. So you want immutable values, you want pure functions, you want some primitives, some concurrency primitives to help you put you have all these threads working. You need to put the answer back together once they're all done. So you need something to help do that. So I would say that it's the object-oriented where you kind of put a little bit of state in every object and just make this big graph of objects. I would say that was the mistake.
Yeah, interesting. And that doesn't seem nearly as controversial as I think people would think. So it sounds to me like if you want to maybe we can back up a little bit and juxtapose, functional programming and non-functional programming. It sounds like it all starts at side effects. Like that's the big argument. State.
Yeah, state, side effects. And so just to be clear, no one thinks that side effects are bad. They're actually necessary. If your program, all it did was use the CPU and then you never knew what happened, it wouldn't be very useful. But what's happened is that we've realized that having side effects, all throughout your code that aren't necessary are actually making it harder to reuse your code. They're making it harder to think about what your code is going to do. By separating out the side effect or the effect, let's not, they're not all side effects. Some of them are, why you call the function. But by separating it out and having a pure calculation over values, you can actually do a lot more reasoning. You can put the calculation on different threads. You can put it on different machines. And so that's really the sort of umbrella under which the functional programming works.
So the state, when people say that the problems with non-functional languages are managing state, it's not the state or the side effects, it's the complexity that comes from those state machines that we end up managing. You add a Boolean, it's fine. Okay, there's two states. Now you add 5 or 6 Booleans, and now it's this Cartesian product of complexity.
Yeah, for sure. And when you have something that is supposed to read a value, but it actually also counts the number of reads, or it is supposed to send a message, but it also writes something to a local variable or a global variable. And those things, like you can't separate them out. And so you think I'm just sending an email when you're also changing all these other things. Mm-hmm. And when you are actually just doing a calculation, like let's say I don't think anybody does this anymore. I hope people don't. But when I was writing C back in the day, like we would reuse global variables, like, oh, this is an int. I need an int. Let me just use that one. And, now it seems silly, but that's what we did back in the day. And, you would set it to 0 and then start counting into it. And then you would be done with it. And the other code was just supposed to know, like, don't touch that while I'm working. Right. And those kinds of assumptions, they require a discipline. And if you could turn that discipline into just a constraint that the language imposes on you, you actually don't have to worry. You can relax a lot more. You can use that, that same construct in different ways. You don't have the mutability. So you're able to count lots of different stuff instead of just that one loop that you had that's supposed to be counting. And, you can count different things at the same time.
Mm-hmm. And there's inputs and there's outputs, but I understand that one of the things that we forget about when we're writing kind of declarative code or imperative code or more programmatic step-by-step code is hidden inputs. Right. Things that are not explicitly called out as an input. Like, for example, if you new up a date in the middle of a function, even, that date's going to change. It's now become a hidden input, but it's buried 10 lines in somewhere. And because you're not explicit about it, it's a dependency in there that you're not realizing.
Right.
And it's hard to test.
Yeah, exactly. It's super hard to test because every time you call it, it's a different time. And, so in a functional world, what you would do is you would pass that date in. And so then you could construct the date in your test however you want. And that way, your test is always going to do the same thing.
So can that be built into the language so you could be forced not to do that? Is that how we end up doing things like inversion of control and dependency injection in non-functional languages? Yeah.
So, the way that you would do that is using the type system. So if you had a Haskell-style type system that includes type inference and a concept of I/O that's part of the type system and also part of the language itself, I/O is supposed to capture all of that. Whether it's I/O like I/O, input, output. So anything coming off the network, writing to disk, anything that the process in memory doesn't control. Also the time, the clock is another input. So in Haskell, the way it works is if you want to do something like that, you have to be very explicit and you actually have to pass that value in from the top. So you can't just in the middle of a function that's supposed to be, summing some numbers, grab a time or a random number or something like that.
Okay. Is that what's called a pure function?
Oh, good question. So yeah, a pure function is a function that is only a calculation from the arguments, and all it does is return the value.
Okay. So then if all the inputs are declared or called out as inputs and nothing's hidden, then that is pure or quote unquote superior to one that might have hidden inputs or outputs.
Right. Superior in the way that you get some guarantees, right? You know that every time I call this, I'm going to get the same answer back. And I can call it as many times as I want, and I'm not going to have effects on the world, right? So, the classic example is firing a missile. You can't call that function twice because it'll shoot off 2 missiles. And so you want to have a function that, say, calculates all the, the number of missiles that it needs to fire separate from actually firing them.
Okay. Well, if I know about side effects, if I know about what's bad and what's good and what's pure and what's impure from a functional perspective, couldn't I go and write Java or C# as if I were writing a functional programming language? I could make sure all my inputs and outputs are called out. I could change my style. And would I be turning it into a functional programming language, or would I just be leaning in that direction?
So you can definitely do that. A lot of people have tried. So there are success stories in that area, especially now that Java has lambdas. It's a little bit easier to write those kinds of things. What I've heard though from the non-success stories is that it's more code, right? Because you're actually going to be writing around the idioms that have been optimized in Java. And then also, your teammates are going to be mad because they've learned all these other idioms and stylistic choices, and now you're breaking all of that, and they don't know what your code is supposed to be doing anymore. They don't want to take the time to learn all the stuff that you know.
Okay. So then that implies that a functional programming language is one that is encouraging me or pointing me in that direction to avoid side effects and to avoid impure functions without it messing up everyone else's flow.
That's right. It's more a matter of defaults and, like you said, pushing you in that direction. For instance, in Clojure, writing a function is really easy. All the data structures are immutable by default, so you get that. And there's no guarantee that your function is pure, but it's super easy to write one that's pure because the functions are very short, and it's just easy to see that you're not calling something like a print line or something.
Mm-hmm. There's a great blog by Chris Jenkins about functional programming, and in it they say that a functional programming language is actively hostile to side effects.
Yeah, that might be a good way to put it. Yeah. I like to think of it like, so if you want to go to the store and buy some stuff, right? You're going grocery shopping. And let's say you need 2 gallons of milk. So you go to the store once, you buy a gallon of milk, you come home, and then you go back to the store and you buy a 2nd gallon of milk and come home. If all you had was a function buy, or a method, go buy a gallon of milk, that's how you would have to buy 2 things, right? But what you could do instead is sit at home, and on a piece of paper you make a list, and you're doing all this calculation in your head, what do I need? And you're making a note, you're making a representation of all the stuff you want to buy. And then you have a function that takes you to the store, and you give it a list, and it will just run through the list and buy everything on your list. And so that separate calculation is something we do every day in our lives. But somehow in computer programming, we mix it all up. You're well, I'm right in the middle of this loop. I might as well just fire off this email instead of calculating all the emails I'm going to need ahead of time, right?
Okay. So when let's talk about this in the context of getting a job.
Okay.
This isn't a matter of just go and read about Clojure and say, I'm going to learn all of the keywords. It's how do you express as you're trying to go out there and transition your job that you really understand this from an idiomatic perspective, that you understand what it means to be functional as opposed to just being able to hack something together. That's
a really good question. So understanding this idea of pure functions is super important. You'll probably, if you're in an interview, you would probably be asked to explain, what's a side effect? What is a pure function? But
oh, good. I'm glad they listened to this show.
Yeah. Now you know, you got your job, right? The other thing is that, when you start to like build more complex systems than something that just calculates one value, you start to build like data transformation pipelines. And it's kind of like when you're doing bash scripting on the command line where you're piping commands together. You have one function that's calculating something, and then another thing is taking that value that it calculated and turning it into something else, and then another thing that's turning it into something else. And then at the end, you can take that and maybe just run a loop over it and send off your emails or whatever you're doing. And so that's another kind of milestone on your journey when you're becoming a functional programmer. So I would talk about that at the interview. The next thing is getting to higher order programming. And that means functions that take functions as arguments. And so because you're using pure functions, you actually feel very safe just giving your function to another function to run for you. And this is often called dependency injection in the object-oriented world. Except you're not injecting an object, a piece of state with methods. You're injecting the function. So you might say, hey, I have a list. Give me a new list, but with all the even numbers removed. Right? And so you're passing in to the filter function. Well, if you want all the even numbers removed, you would pass in the odd predicate. So a function that returns true if the number is odd. And so filter odd and then your list, and you get back all of, a new list, because it's immutable. So a new list of only the odd numbers. And so once you start thinking in terms of that, you realize that there aren't that many useful shapes of data. There's like ordered lists. There's associative data structures like hash maps, dictionaries, where you have a key value, and then that's basically it. There's sets, which are like bags of stuff, non-ordered, and then each item is unique.
So when I hear this word predicate and I hear all these different kind of computer sciencey words, those are the ones I think that scare people off, like we said.
Right.
But a predicate's like a filter criteria, right? Like it's the thing that returns true or false, and then you use it to filter lists of things.
That's right. It's just a regular function, a pure function that will take an argument and return true or false. So it does some check on the argument. So you could have a function called odd that takes a number or an integer and it returns true if it's an odd number. You could have one called even that returns true if it's even. And so you can then pass this into a function that expects a predicate, like filter. Filter will take a sequence or some collection and return a new collection with only keeping the stuff that passes the predicate. So you have a list of numbers and you pass it to filter with the odd predicate, you'll get a new list of numbers with only the odd numbers in it. And because there's only certain shapes of data, so filter works on a sequence, right? And then there's like associative shapes. So sequences have an order. Associative doesn't have an order, but it has like this relationship between the keys and values. And then there's sets, which are just collections with no order, but you can check if something is in there, and you can also like put the same thing in twice and it only gets put in once. And because there's only these certain shapes, you just learn a bunch of these higher order functions that operate on the shapes and put them in a pipeline, and you're just piping stuff through. I mean, I guess it's kind of like, if your audience is familiar with some of the Unix commands, like the early Unix commands, where, ls just lists all the files in the directory, one on each line, and then you grep it, and it shows you all the ones that match, and then you pipe it to something else, and maybe you sort them and then you count them. You can do all sorts of stuff with them, and you're just chaining up these commands together.
Right. That's a really clean way to explain it to people. Like ls doesn't change anything. It never, ls is guaranteed to never change stuff.
Right.
And grep doesn't change stuff either.
Right. All it does is it reads in lines and then only prints out a subset of those lines.
Okay. So then this kind of brings us to function composition, where I go and take 5 or 6 functions, and awk and set and grep and JSON-C or whatever, and combine them, and then I could make them their own function and then combine that. And then now you're building stuff up, except you're doing it with pieces of functions and functions of functions, as opposed to, as I like to say, multiple nested for loops, right? Which is what it ends up being in non-functional languages.
Exactly. I mean, because what happens in Unix is all you really have are lines of text, right? Like that's what everything understands. So it's very flat. If you need to do anything more sophisticated than just, read it as text, maybe like it's a JSON per line. Well, then you need another like program that can go in and read a line of JSON, and you I don't even know how you do this in Unix, but you need to run that command for every line, and then inside that it's like now it's nested, so you have to do all this stuff inside of that, and it gets really complicated, which is why in a functional language you will get more nesting in your data structure, but because you're operating at a higher order, you're often able to, I guess, keep the pipeline flat is how you think of it.
Mm-hmm. Very cool. So you can go to purelyfunctional.tv, which is Eric's website, and he's got video courses. He's got a guide that you can get on his mailing list. There's a whole section on job resources for both Haskell and Clojure. And you can basically get onto the newsletter to start and check out some of his great video courses. He's got a whole system, and the whole focus of your website, and I really like this, because rather than just saying, here's a bunch of videos, here's a bunch of stuff, your focus is, if you want to move your career, you want to change your job from doing imperative programming to functional programming, you're basically setting people up for success with that being the goal.
Yeah. And now you should understand the purely and the functional. It's like a play on words.
Yeah, nice.
That's all I talk about is functional, and it's pure, and yeah, there you go.
That's great. And I'm going to put links to all of this in the show notes, as well as some of the great free courses. He's got like 13 hours of great free courses about Clojure.test and data modeling and all kinds of stuff. So you can see his style of teaching. And if you check it out, maybe purchase some things. Thanks so much for chatting with me today.
Thanks so much, Scott.
This has been another episode of Hansel Minutes, and we'll see you again next week.